All right, let's go ahead and get started on the stuff. Just to let you guys know, pay attention to the front page of your Canvas site because I've got your next homework set posted and stuff. I want to finish up the last part of 8.5 here and move on into section 8.6 today. So remember last time we were giving you guys a power series and we're asking you basically two questions. Interval and radius of convergence. And to figure out the interval and radius of convergence of a power series, you pretty much do one thing. Do the ratio test, and then you take the limit as n approaches infinity of the absolute value of an plus 1 over an, and whatever you get left over, you're going to be forcing it absolute value less than 1, L less than 1 makes it converge, and then you find your interval of convergence. But then you had to do one last thing at the end, because the ratio test states that you can't tell what's going on at the endpoints. You have to test your endpoints. So reminding you of that fine fact is we have a little nice little theorem up here about the convergence of a power series. It says this, that quote, for the power series f of x equals the sum as n goes from 0 to infinity of Cn x minus a to the n, you've got three different possibilities. The three different possibilities are the series converges only at x equals a. You have a point of convergence. Or number two, the series converges for all x. That's from negative infinity to infinity. All real numbers is your interval of convergence. And number three is you actually have a particular interval. The series converges when the absolute value of x minus a is less than r, and it's going to diverge when the absolute value of x minus a is greater than r for some positive number r, where r is your radius of convergence. But you'll notice right there where it says equal to, it doesn't say, because you have to, quote, test the endpoints. Some endpoints work, some endpoints don't work. So if you remember the last two examples I did for you guys last time, we had this particular power series, and I told you guys the trick, where the factorial was in the numerator. And when you factorize in the numerator, the series is going to almost always diverge, except for one point. You have your point of convergence, the actual point that makes your power series zero. That's what they're referring to here, a point of convergence. Then we had this series where the factorial was in the denominator. And when I did my ratio test on this and took my limit into infinity, I got 0, and 0 is always less than 1. We got an interval convergence from negative infinity to infinity. That's your case number 2, all real numbers. But most cases are on case number 3, where you actually get some kind of absolute value of x minus a, and you have to force that to be less than r, and then solve for x in the middle to get your interval of convergence and stuff. So in this particular example, if you look at this, if you're given, so we are given the fact that the power series, the sum as n goes from 0 to infinity of Cn x4 to the n is convergent. Does it allow for the following other series to converge? The answer is pretty much yes or no. Are these guys going to converge? So what they basically are saying here is this. We're given this thing is going to converge. And you notice this is the series that we're talking about here. So you're talking about your x minus a. This part right here has to be pretty much less than or equal to the 4 part. This is the x minus a is comparing it to the 4 that's being raised to the n. So this is what my deal is here. So pretty much my r equals 4. So if your r equals 4 and it's anything less than or equal to this 4 is going to converge, then look at number A here, letter A, 6A. Does that imply that the sum as n goes from 0 to infinity of Cn times negative 2 to the n, is this going to converge? The answer is yes or no. Well, since the absolute value of negative 2 is equal to 2, which happens to be less than 4, and we were given that this thing converges. Given that this converges, that does imply that the sum as n goes from 0 to infinity of Cn times negative 2 to the n is convergent. So the answer for this problem is yes, it is going to converge. Any r less than the r that's given. R that's given is 4. So any number x for x minus a that's less than that r will also converge. Your problem is right here. This one, the sum goes from 0 to infinity of Cn times negative 4 to the n. Well, you see your x minus a part here equals negative 4. Absolute value speaking, and absolute value negative 4 is 4. and 4 is not less than 4. Remember, we were given this series converges. We were given this converges, but this is the other endpoint. Because one endpoint converges, does that force the other endpoint to converge? No, that's one we have to check both of them. So the answer for this one, because 4 is not less than 4, this implies that the sum as n goes from 0 to infinity of Cn times negative 4 to the n may not be convergent. The answer is no. We're not guaranteed it's going to be convergent because it's the other endpoint. It may converge. I don't know. But anything less than is going to converge, but not right there equal to, I can't tell. Checking your endpoints. So one last problem before we move on, and it's this problem here. It says find the interval and radius of convergence of this particular power series. It's the sum as n goes from 1 to infinity of negative 9 to the n times x to the n divided by the 10th root of n. What are you going to use? When you hear these words on the test, and I guarantee you're going to hear them, here's a power series. Find the interval and radius of convergence. Typically, what do? Ratio test. So you apply the ratio test to this guy. So this is the limit as n approaches infinity, the absolute value of an plus 1 over an. This will be equal to the limit as n approaches infinity of the absolute value of negative 9 to the n plus 1 times x to the n plus 1 divided by the 10th root of n plus 1 divided by an, which is negative 9 to the n, x to the n over the 10th root of n. This is equal to the limit as n approaches infinity of absolute value. And again, the trick is invert, multiply, and group together like terms. So here you got negative 9 to the n plus 1, x to the n plus 1, divided by the 10th root of n plus 1. And when I invert and multiply, the 10th root of n will go on top, the x to the n will stay on the bottom, and the negative 9 to the n will stay on the bottom. Now, bunches of stuff cancels here. What cancels? Well, your negative 9 to the n plus 1 is the same thing as negative 9 times negative 9 to the n. So this, it turns into negative 9 times negative 9 to the n, and negative 9 to the n cancels with negative 9 to the n. So you're left with negative 9 already, and we'll clean him up in just a second. X to the n plus 1 divided by x to the n. Again, x to the n plus 1 is x times x to the n, and the x to the n's cancel. So you're left with an x. The rest of them have n's on them, so I got to do the limit on that. So this is equal to the limit as n approaches infinity of the absolute value of negative 9 times x times the 10th root of, and I'm going to go ahead and combine these two guys, of n over n plus 1. Now, remember we talked about the law of limits. With limits, you go after where the n's are at. They're inside my 10th root when I combine my 10th root of numerator, 10th root of denominator. And when I take the limit as n approaches infinity, what is the limit as n approaches infinity of n divided by n plus 1? L'Hopital's rule says it's going to be what? 1, but it's going to be the 10th root of 1, but what's the 10th root of 1? 1. Also, what's the absolute value of negative 9? Positive 9. So I'm going to get rid of the negative because it's inside an absolute value. So you're left with 9x. Does that make sense? Now, you're going to force this to be, quote, less than 1. This is the ratio test. And then I'm going to solve for n, which tells me negative 1 is less than 9x, which is less than 1. Then solve for x in the middle by dividing by 9 on all sides. And I get this. Negative 1/9 is less than x, which is less than 1/9. This is almost my interval of convergence. But when I'm using the ratio test to find the interval of convergence, what do I have to do every time once I got an interval? Test the endpoints. So here are the endpoints. And remember, when I test the endpoints, I'm expecting, honestly, to get the exact same series on both endpoints, except one side will be alternating, the other side won't. But I don't know which one's going to be until I actually plug it in. So my endpoints are x equals negative 1/9. Let's plug in that guy. We're plugging it into this series here. This will be the sum as n goes from 1 to infinity of negative 9 to the n times, plugging in for x, negative 1/9 to the n divided by the 10th root of n. They have the same power, so I can factor out that power. This is the sum as n goes from 1 to infinity of negative 9 times negative 1/9 to the n over the 10th root of n. What is negative 9 times negative 1/9? Negative times negative is positive. 9 times 9 times 1/9 is 1. So this is the sum as n goes from 1 to infinity of 1 to the n over the 10th root of n. But 1 to the n power is 1, so this is the sum as n goes from 1 to infinity of 1 over n to the 1/10th power. What kind of series this thing just turned into? You should know it. Got all this stuff memorized. P series. However, P is equal to 1/10, which is less than 1, which means it's going to do what? Diverge, which means I do not want this point in my interval of convergence. Does that make sense? However, now I want to take the other endpoint. The other endpoint was what? X equals a positive 1/9. Now watch what happens when I plug it in. I'm going to get the sum as n goes from 1 to infinity of negative 1/9 times x's 1/9 to the n over the 10th root of n. Again, I'm going to factor out the n on this thing, kind of showing you my math here. This will be the sum as n goes from 1 to infinity of negative 9 times positive 1/9 to the n over the 10th root of n. And negative 9 times 1/9 is negative 1. So this is the sum as n goes from 1 to infinity of negative 1 to the n over the 10th root of n. And what kind of series is this guy? It pretty much was the exact same series as before, except for what deal? It's alternating. And because it's alternating, what test am I going to use? Okay, so the alternating series test. So the Bn, the part without the alternation, is 1 over the 10th root of n. So two things I got to show you. Make sure the terms go down. So 1 over the 10th root of 1, 1 over the 10th root of 2, 1 over the 10th root of 3. Yep, ever so slowly, but my terms are decreasing as the denominator gets bigger. And number 2, when I take the limit as n approaches infinity of the Bn 1 over the 10th root of n, I get 1 over the 10th root of infinity is infinity, which makes it 0. So as the terms decrease and the limit goes to 0, by the alternating series test, this thing's going to converge, which means I want this point in my interval of convergence. So I'll mark that by a equal to here. So to answer the two questions are, find the interval and radius of convergence. Traditionally, we'll write it like this, or traditionally an interval notation. So interval notation, the answer would be parenthesis negative 1/9 to 1/9 bracket. That would be my answer. And what about this radius of convergence? Well, it's b minus a divided by 2. That would be 1/9 minus negative 1/9 divided by 2. 1/9 plus 1/9 is 2/9 divided by 2 is 1/9. My radius of convergence is 1/9. Does that make sense? Ratio test is the key to this stuff, and this is the work you have to show. And then at the end, you've got to test your endpoints. So far, we've been dealing with giving you guys a power series. We gave you this power series and then asked you to find the interval of convergence. Now we're going to switch gears. We're going to make you come up with the power series. Section 8.6 is called power series representation. So hopefully you watched the awesome pre-section video on this stuff, but the big deal is this. We're going to be converting stuff over. We're going to use the famous geometric series. Now, we had the geometric series being equal to being this. The sum as n goes from 1 to infinity of a r to the n minus 1. But to make this thing look a little nicer and cleaner, because we are going to do some calculus on this, this is equivalent, and starting n goes from 0 to infinity of a r to the n. It's the same geometric series, but it looks a little neater to have the n instead of an n minus 1 power on this guy, but you have to have the summation start at 0. And we know that this guy is going to converge to the formula a over 1 minus r, provided the absolute value of r is strictly less than 1. And the nice thing about this is we don't have to check the endpoints on this stuff. endpoints are going to diverge. So here's what we're doing. Here's the gist of it. We are going to look at functions in the form of a over 1 minus r, and then work our way backwards and write them as a series. And with the absolute value, the r has to be less than 1. So these two guys are going to be equal to each other. This is called power series representation. So we did a bunch of problems on the pre-section video for you guys. So in terms of that algebra review, it's the idea of figuring out the pieces and the parts and stuff. So reading off data is going to be the key to this stuff. So for example, on this problem up here, we know with the absolute value of x has to be less than c, that means that negative c is less than x, which is less than c. This is my quote interval of convergence. So if I had to write ax minus 2 in the form of, 5x minus 2 in the form of ax plus b, what does a have to be equal to? Now you read off your coefficients, 5. What does b have to be equal to? Negative 2. But in that same light, look at this problem. This is the goal. If I have 2 over 1 minus x, and it's in the form of a over 1 minus r, what's a and what's r? Well, this would imply that a would be the numerator, which is 2. The 1 and the minus match up, so the r would be equal to x. A is 2 and r is x. But look at this one. I got 1 over 1 minus x. I want to write in the form of a over 1 minus r, so I would have to write this as 1 over 1 minus negative x. And that would imply that my a would be 1, but my r would be negative x to put it in this form. The idea of reading off data. Does that make sense? But now the last one is a little more tricky. So here's the trick on this one, and you'll see me use this quite a bit. I've got the function 2 over 5 plus x squared. I want it in the form of a over 1 minus r. So I've got 2 over 5 plus x squared. The first thing I want to have in this spot is a 1. I need to convert a 5 into a 1. You figure out a 5 into a 1, you need to multiply by 1/5. But whatever I do to the denominator, I got to do to the numerator. And I'm going to distribute. This will give me 2/5 over 1/5 times 5 is 1 plus x squared over 5. But now I've got my 1 in the right spot, but now I need to get the sign in this guy. How do I rewrite a plus in terms of a minus? A plus is a minus a negative. So this would be equal to 2/5 over 1 minus negative x squared over 5. Now you've got it written in the form of a over 1 minus r. You can tell me that a is equal to 2/5 and r equals negative x squared over 5. There's my answers. And some other little aspects of putting these PC parts together on these series. You got to look at things as being a product and quotients here. So if f of x is equal to the square root of 2 times the square root of x plus x and g of x equals x, find the composition of f times g. So f times g of x would be 2 square root of x plus x times x. And f divided by g of x would be equal to 2 square root of x plus x divided by x. Basically, you're going to put together functions, multiply them, and divide them. And if you wanted to, you could clean this up by distributing. You could clean this up by taking that single term and dividing into both terms. So here, when you distribute, remember this is x to the half, you get 2x to the 3 halves plus x squared. Here, you can divide by that single denominator. And you clean them up to get, remember this is x to the half. When you divide by an exponent, you get, you should subtract exponents. When you divide, you subtract exponents. That'll be 2x to the negative 1/2 plus 1. So different ways you can write this stuff. And of course, you need to know about composition of two functions. F of g of x, that's the same thing as f composed with g of x. F is on the outside, he's your commander, and so you write it with little spaces for the x's. It's something squared plus 2 times something, and replace the g with the x. You put in your 2x here and 2x here and clean them up. That gives you 4x squared plus 4x. This is kind of the algebra stuff and cleaning up stuff that you're going to need to do when you start manipulating power series. So, here's the idea right here. Power series representation. It's a game. of turning functions into series. And you ask yourself, why in the world do I need to actually do this particular game? Well, number one, computer science. Programming is key to this stuff. That means all of us this 21st century that we live in. So, we're going to convert these kind of problems into power series. And you're going to see the power of this stuff towards the end of the class today. So, as I mentioned to you before, we're going to be using the new and improved notation of the geometric series, which is the sum as n goes from 0 to infinity of AR to the n. And remember, it converges to, which means it's equal A over 1 minus R, provided the absolute value of R is less than 1. And also this is for web work notation. F of x is equal to the sum as n goes from 0 to infinity of Cn times x to the n. Well, first rule, you plug in the first number. That would be C0 plus C1x1 plus C1x squared plus C3, so C2x squared plus C3x cubed plus C4 x to the fourth, dot, dot, dot. Now let me explain the notation. The coefficient in front of the x has the same power. So C0 is your constant term. C1 is the coefficient in front of x. C2 is the coefficient in front of x squared. C3 is the coefficient in front of x cubed. Because Weber's going to ask you what's C4, you got to tell them what the coefficient in front of x to the fourth is. And remember this. If you have like 1 plus x cubed, there is no x term, there's no x squared term. So C1 and C2 would both be 0 because there's no x term and there's no x squared term. Does that make sense? This subscript represents the coefficient in front of x to that power. So when you do not have an x squared term in a problem, C2 would be 0. That's going to be the trick on web work. So here we go. Here's some examples. We want to write these functions as a power series. So, as we mentioned before, we're trying to turn them into A over 1 minus R, so I can write it as the sum as n goes from 0 to infinity of AR to the n. That's the goal. And my interval of convergence is going to be the absolute value of R has to be less than 1. So on this problem, it's pretty straightforward. This is A over 1 minus R. So A equals 2 and R equals x. So as I write it as a power series, this is sum as n goes from 0 to infinity of 2 times x to the n. And please understand, this means that f of x is equal to 2 over 1 minus x. That's equal to the sum as n goes from 0 to infinity of 2x to the n, where the absolute value of r, which is x, is less than 1, which means that negative 1 is less than x, which is less than 1. So let me explain to you. In this particular problem, this function, 2 over 1 minus x, and the power series, the sum as n goes from 0 to infinity of 2x to the n, they're equal to each other as long as you plug in numbers between negative 1 and 1. And you ask yourself, well, what's the big deal about that? Well, if you write this power series out, this one's pretty easy. You get 2 when you plug in equals 0, plus 2x, plus 2x squared, plus 2x cubed, plus, it's an infinite series. But instead of plugging stuff in here, you could plug stuff in here. And if you look at it, all you're really doing is multiplying, powering stuff up, multiplying, and adding. Add, subtract, multiply, and divide. This is where we get the computer science aspect of taking calculators and turning them into computers. We can program interesting functions into power series. Okay? You'll see this in a second. Well, this was not too hard. You can do the math on that one. Yeah, but wait, I'm going to change the rules in just a second. Careful. So pay attention. This is high-level math stuff. Again, this is the type of math that you're not just going to have memorized for Calculus 2 and pass Test 4 in the final exam. You're going to see this stuff again in differential equations. You're going to see this stuff again in your 3,000 and 4,000 level science courses. Power series, especially you guys that are electrical engineers, you're going to see this stuff in circuits, and especially with signals and stuff like that. Power series are going to haunt you. Differential equations, we got series called Fourier series and Fourier transforms, and we also have Laplace transform. We got a lot of different series coming in your future. You got to know this stuff. This is not just memorize it for the moment and pass the class and go on the next. This stuff is going to haunt you. If you don't know it in your upper level classes, you're in trouble. They expect you to know it now. Try this one. G of x equals 1 over 1 plus x squared. You want to write this as a power series. So you want to rewrite this as a over 1 minus r. This is 1 over 1 minus negative x squared. So writing it in that form, a would be 1, r would be negative x squared. But you got to clean this stuff up. So 1 over 1 plus x squared would be equal to, the sum as n goes from 0 to infinity of a, which is 1, r, which is negative x squared to the n. A, r to the n. But you want to clean it up. This will be the sum as n goes from 0 to infinity of negative x squared. When you distribute the n, that'll be negative 1 to the n, x squared to the n. I just distribute the n because this officially is negative 1. But, clean it up. Power to a power, what do you do with the powers? Multiply. So this will be the sum as n goes from 0 to infinity of negative 1 to the n, x to the 2n. This is your power series representation formula. And these two functions are equal to each other provided the absolute value of r is less than 1. Absolute value of negative x squared has got to be less than 1. But the negative inside of an absolute value goes away. Absolute value of x squared has got to be less than 1, and then take the square root. So you get the absolute value of x is less than 1, which means negative 1 is less than x, which is less than 1. This is your interval of convergence. But if you wrote this out, and again, this is the way WebWorks is going to have you guys do these problems here. You start with n equals 0. Negative 1 to the 0 is 1. 2 times 0 is 0. X to 0 is 1. It'll be 1. Now plug in 1. That'll be minus. Plugging in 1, that'll be x squared. Plug in 2. Negative 1 squared is plus. 2 times 2 is 4. That's x to the 4th. And catch a pattern. Minus x to the 6th plus x to the 8th plus dot, dot, dot. I got a question for you. This is for WebWork purposes. What's C0? What's C1? What's C2? What's C3? And what's C4 equal to? What's C0? You nailed it. What is it? 1. What's C0? Excuse me. C0 is 1. What's C1? What's C1? It's 0. There's no x term in this thing. C1 is the coefficient in front of the x. This goes from 1 to x squared. It's 0. What's C2? Negative 1, the coefficient in front of the x squared. What's C3? 0. There's no x cubed term in it. What's C4? C4 is the coefficient in front of the x to the 4th, which is 1. Do you understand what I'm telling you about WebWork? The C subscript is the coefficient in front of x to that power. If there's no x in this term, there's no x cubed in this term, so they're both zeros. This is WebWork. Look at this guy here. 1 over 2 plus x. So again, I'm going to turn this 1 over 2 plus x into this a over 1 minus r. I need to make the 1 there. I do make a 1. I'm going to multiply both the numerator and denominator by a half. This is going to give me 1/2 divided by distributing 1 plus x over 2. A half times 2 is 1 plus x over 2. Now I got to put the negative in there. A plus is a minus a negative. So this would be 1/2 divided by 1 minus negative x over 2. So here we go. In this problem, a equals 1/2, and your r would be negative x over 2. So writing it as your series, the sum as n goes from 0 to infinity of a, which is 1/2, your r, which is negative x over 2 to the n. But here's the deal. This is not how we're going to write up the answer in terms of multiple choice questions. We're going to make you clean this thing up. Cleaning it up, I'm going to distribute my power of n. Remember, negative represents negative 1 times x squared over 2. So this is sum as n goes from 0 to infinity of 1/2 times negative 1 to the n times x squared to the n over 2 to the n. I distribute the n throughout all these guys. Clean them up. This is going to be the sum as n goes from 0 to infinity of 1/2 times negative 1 to the n, x to the 2n divided by 2n. Combine. What is 2 times 2 to the n? Remember we used to pull stuff off? Well, now we're going to put them back together again. What's 2 times 2 to the n? When you multiply, you add exponents. What does that give you? 2 to the n plus 1. So this is the power series. The sum as n goes from 0 to infinity of negative 1 to the n, x to the 2n, over 2 to the n plus 1. This is your power series formula. But we're going to want you to write this thing out. Plug in a 0. Negative 1 to the 0 is 1. 2 times 0 is 0. an x to 0 is 1, so that'll be 1 over 0 plus 1 is 1, that'll be 1/2. Plug in 1, that'll be minus x squared over 1 plus 1 is 2, 2 squared is 4, plus, plug in, this is 0, plug in 1, plug in 2. Negative 1 squared is plus, 2 times 2 is 4, x to the 4th. 2 plus 1 is 3, 2 cubed is 8. Let's do one more. That'll be plug in 3. Negative 1 cubed is back to negative. 2 times 3 is 6, x is 6 over. 3 plus 1 is 4, 2 to the 4th is 16, plus dot, dot, dot. So I ask you the question again. What is C0? What's C1? What's C2? What's C3? And what's C4? What's C0? 1/2. Question. Where did I get the x squared from? I don't know. I look back up here. Let me change the problem a little bit. Here it is. Okay. Sorry. I looked up here and looked down at the problem. Sorry. Okay, so thank you for noticing that. Now I changed the problem here. So x squared. There we go. So, all right. All right, so, and that's where I got the x squared from, was right there, because I went back and looked at that thing right there, and I have to separate my problems is what I need to do. But does that make sense, though? Thank you for noticing that. All right, so I changed the problem for the x squared, but nevertheless, C0 is 1. C1 would be what? 0. What's C2? Neg sign goes with it, negative 1/4. What's C3? 0. What's C4? 1/8. Again, I'm doing this purpose for web work purposes. And now that there's an x squared on this thing, because I just changed it, what is the interval of convergence going to be? The absolute value of r had to be less than 1. Your r is negative x squared over 2. So get rid of that. Absolute value kills off the negative. So this is x squared over 2 is less than 1. But you got to kill off the square before you do your double-sided inequality. So you take the square root of both sides. That gives the absolute value of the x divided by the square root of 2. It's got to be less than 1. The square root and the square kill each other off. You're still with the left with the absolute value. So this tells me negative 1 is less than the square, x divided by the square root of 2 is less than 1, which means negative square root of 2 is less than x, which is less than square root of 2. This is my interval of convergence and stuff. So we're doing the same stuff as what we did before. But this series and this series, 1 over 2 plus x squared, is actually the same series. Does that make sense? Provided you only plug in numbers between negative 2 and 2. And you go, why is this stuff so important? Well, take a look at your next theorem up here. This is calculus class. Here it is. What this theorem is telling you is this. You can differentiate and integrate power series. So, if you got yourself a power series, which is C0 plus C1 times x minus a to the first, plus C2 x minus a squared, plus C3 x minus a cubed, plus dot, dot, dot. Which is, if you write it as a series, this is the sum, as in goes from 0 to infinity, of Cn x minus a to the n. So, that's your power series. You can take the derivative of a power series. You can, if you wrote out the terms, you can take the derivative of each term. Derivative of C0 is, being a constant, is 0. Derivative of C1 x minus a to the first, derivative of that respect to x would be C1. Derivative of C2 x minus a squared, power rule, the 2 pops out front, C2 x minus a to the first. Derivative of C3 x minus a cubed will be 3 times C3 x minus a squared. Don't forget it's chain rule. Times derivative of the inside, but derivative of inside is 1. Or, better yet, you can take the derivative of this guy with respect to x, and remember, c is their arbitrary constant. So, the derivative of Cn x minus a n, you bring down the n of n times Cn times x minus a to the subtract 1, n minus 1, officially times derivative of the inside, which is times 1, but here's the trick. When you take a derivative, you start with the traditional power series as n equals 0. The derivative, because the first term is a constant. What's the derivative of a constant? 0. The power series on a derivative starts at 1 because the first term is 0. Derivative of a constant is 0. So the first term is 0 on this guy. However, you can also integrate. So you can integrate each one of these guys, and they're integrating with respect to x minus a. So the integral of C0 is C0 times x minus a. Integral of C1 x minus a would be C1 x minus a squared over 2. Integral of C3 x minus a cubed would be x minus a squared, would be C2 x minus a cubed over 3. The next one's going to be C3 x minus a cubed would be C3 x minus a to the fourth over 4. And if you keep going, you're integrating this guy. This will be integral of Cn x minus a to the n. You add 1 over add 1. That'll be Cn x minus a to the n plus 1 over n plus 1. But don't forget, you got a plus c arbitrary constant integration, but you start with the same summation. So you can integrate and take derivative of these guys. That's what we're telling you guys. So, in derivative, n pops out front and you subtract 1. With integrals, you add 1 over add 1. We're typically doing the basic power rule. Now think of this from a programming perspective, why this is important. So, here's a real problem right here. Look at this guy. F of x is equal to the arctangent of x. We want you to write a power series for this guy. The other guys were easy because they kind of look like a over 1 minus r to begin with. This dude don't. He looks like arctangent of x. However, here's the trick. This is what we want. But I happen to notice that when I take the derivative and I actually pass calculus 1, I know the derivative of what the arctangent of x is. What's that? 1 over 1 plus x squared. Things we memorized from calculus 1. This is your derivative of the arctangent. And this guy looks like a over 1 minus r. Almost. So we need to fix him up. This is going to be 1 over 1 minus negative x squared. So here a would be 1. And your r would be negative x squared. Does that make sense? Now, write him as your series. So this is a formula for my derivative. This will be the sum as n goes from 0 to infinity of a, which is 1, r, which is negative x squared to the n. Remember, the whole goal is to convert a over 1 minus r into a times r to the n. The sum as n goes from 0 to infinity of a r to the n. This is what we're doing. So I've got this guy, but I want to clean him up. This would be equal to the sum as n goes from 0 to infinity of negative 1 to the n power. What is x squared to the n also known as? Power to a power you multiply. What do you get? X to the 2n. This is the power series. And here's the deal. Also, remember, the absolute value of r had to be less than 1, which means the absolute value of negative x squared had to be less than 1. Take the square root of that. Absolute value of negative goes away. So the absolute value of x is less than 1, which means negative 1 is less than x, which is less than 1. This is your interval of convergence for this guy, between negative 1 and 1. Same stuff we were doing before. But here's my problem. We just converted this guy to a power series, but we didn't convert the problem to a power series. We converted its derivative to a power series. So how am I going to get the original function to a power series? What do you got to do to the derivative to get the original function back again? Integrate. So just to remind you, the arctangent, or tangent inverse of x, is equal to the integral of 1 over 1 plus x squared dx. It's the integral of the derivative function. Does that make sense? So I need to integrate. I got this as a power series. He is the sum as n goes from 0 to infinity of negative 1 to the n, x to the 2n. So here comes the big work right here. How do I integrate a power series? To take a derivative of a power series, you start with n equals 1. When the original problem started with n equals 0. You start with n equals 1 because the first guy is a constant, and derivative constant is 0. But we're not taking the derivative of this guy, we're integrating them. So when you integrate, you get the same summation again. The sum as n goes from 0 to infinity. The constants, negative 1 to the n, stays there. You've got to integrate the x variable. What is the integral? And this is pure rules. What's the integral of x to the 2n? To integrate x to a power, what do? Add 1 over add 1. This gives you x to the 2n plus 1 over 2n plus 1 and plus c because you integrated it. I just created a power series for this guy. But one other thing. I need to figure out what the c is. So you've got to know a particular point about your function. This is tangent inverse of x. Note What is the tangent inverse of 0 equal to? If you don't know, use your calculator. It's kind of sad if you don't. The tangent inverse of 0 is 0. So when I take the tangent inverse of 0, that's going to be equal to the sum as n goes from 0 to infinity of -1 to the n times 0 to the 2n plus 1 over 2n plus 1 plus c. What's a bunch of stuff with 0 being added up? What is this thing going to be equal to? 0. 0 to any power of 0 divided by whatever is still 0. Sum up a bunch of zeros, you get 0 plus c, and that's supposed to be equal to 0, which tells me c equals 0 in this example, which tells me, therefore, your power series for the tangent inverse of x is the sum as n goes from 0 to infinity of -1 to the n, x to the 2n plus 1 over 2n plus 1. Okay? Now, let's write out some of these terms, because I want you to understand what this guy really is. So I'm going to plug in n equals 0. -1 to the 0 is 1. 2 times 0 is 0 plus 1 is 1. That'll be x. 2 times 0 is 0 plus 1 is 1. So the first term is x. That's plugging in equals 0. Plus plugging in equals 1. -1 to the first is negative. 2 times 1 is 2 plus 1 is 3. That'll be x cubed over 3. Now plug in n equals 2. -1 squared is 1. 2 times 2 is 4 plus 1 is 5. Over 2 times 2 is 4 plus 1 is 5. Minus, what do you think the pattern is? Well, when I plug in n equals 0, 1, 2, plug in 3. -1 cubed is negative. 2 times 3 is 6 plus 1 is 7 over 7. And I think after this you can catch a pattern. You don't actually have to plug in the numbers. This is the power series for the arc tangent of x. I want you to understand what your calculator is doing and why this stuff is so important. Here it is. If on my calculator I type in, now I'm in check my mode out, I'm in radian mode here. If I do the tangent inverse of, I don't know, 0.5. I got 0.463647609, right? How does the calculator do this? That's what you should be asking yourself, your question here. How does the calculator do this? Well, instead of plugging tangent 0.5 into this, plug 0.5 into your power series. Let's see here. This will be 0.5 minus 0.5 cubed divided by 3 plus 0.5 to the 5th divided by 5 minus 0.5 to the 7th divided by 7. And I'd only stopped at 4 terms here, but let's see what we get. Okay? Do you notice that the numbers are really darn close to each other? And wait a minute. Let's do this. Let's do one more term. What do you think the next term is going to be? It's going to be what? Plus 0.5 to the odd power, 9th, divided by 9. And what do you get? You get this guy here, right? And when I did the tangent inverse of 0.5, notice we're getting very, very close to the same number. Does that make sense? And I'm only writing out a few terms. Typically, the calculator is going to take this thing out to about 5 or 6. Basically, it's going to depend on the power and stuff like that. But my point is this. When I plug numbers into this, it's the same as plugging numbers into this. But when you plug numbers into your power series, which is a polynomial, you're multiplying a bunch of stuff, you're dividing, you're adding and subtracting. You turn fancy formulas into add, subtract, multiply, and divide. And now we can program calculators to do this and replace it with the tangent inverse. This is how the calculator is actually working. It's using a series to figure out what these values are. Very important stuff in terms of programming. Does that make sense? So, remember this. This is a very important. And one last thing here. Here's the deal. You remember your interval of convergence between -1 and 1? Whether you integrate or derivative, your interval of convergence will remain the same. It's still going to be between -1 and 1. So I can, as long as I plug in numbers, and notice I plugged in 0.5 into this thing, which is between -1 and 1, these two functions are going to go to the same thing. But, so you look at this guy here on your web work problems here. It says this. Find a power series representation for f of x equals x over 8 plus x squared. This is already in the form of a over 1 minus r, well, almost. It is f of x equals x over 8 plus x squared. We want to convert it to a over 1 minus r, so we can write this. The sum is n goes from 0 to infinity of a r to the n. Okay? Well, the first thing I need is I got to get the 1 in that spot. So I'm going to multiply both the numerator and denominator by 1/8. That gives me x over 8 divided by, distributing here, that'll be 1 plus x squared over 8. You got to get the 1. And notice the trick. You multiply by 1 over whatever that numerical value is in this form. In this case, it's the 8. Now I got to get the minus in here. So f of x is going to be x over 8 divided by 1. To change a plus into a minus will be minus a negative x squared over 8. This right here tells me a is equal to x over 8 and r equals negative x squared over 8. Converting it into my formula, this means your function is going to be the sum as n goes from 0 to infinity of a, which is x over 8, times r, which is negative x squared over 8 to the n. Now you want to clean this guy up. Distribute your powers, your n power. This is negative 1 times x squared over 8. This turns into the sum as n goes from 0 to infinity of x over 8 times negative 1 to the n, x squared to the n, over 8 to the n. Power to a power you multiply, so when you clean it up, you get f of x equals the sum as n goes from 0 to infinity of negative 1 to the n. Power to a power you multiply, that gives you x to the 2n, but there's one more x. And when you multiply, what do you do with the x's? You add their exponents. That'll be x to the 2n plus 1 over 8 times 8 to the n is 8 to the n plus 1. When you multiply, you add exponents. I'm playing big time 4th grade arithmetic in terms of putting together my powers. When you multiply, you add exponents. Power to a power, you multiply. When you divide, you subtract exponents. That stuff. Now, this is web work. They want you to write this thing out. So when I write this thing out, I'm going to give you this. Okay, we start with n equals 0, n equals 1, n equals 2, dot, dot, dot. So here we go. N equals 3. Now, they did say the first 3 non-zero terms up here, and this will actually give me 4 of them, but there we go. Negative 1 to the 0 is 1. 2 times 0 is 0 plus 1 is 1. That'll give you x. 0 plus 1 is 1. That'll be x over 8. Now plug in 1. Negative 1 to the first is negative. 2 times 1 is 2 plus 1 is 3. X cubed over 1 plus 1 is 2. 8 squared is 64. Now plug in 2. Negative 1 squared is plus. 2 times 2 is 4 plus 1 is 5. That'll be x to the 5th divided by 2 plus 1 is 3. 8 cubed is 512. And while we're at it, plug in one more, C3. Negative 1 cubed is negative. 2 times 3 is 6 plus 1 is 7. Over 3 plus 1 is 4. 8 to the 4th is 4,096 plus dot, dot, dot. But this is for web work purposes. Please tell me, what's C0? What's C1? What's C2? What's C3? What's C4? What's C5? What's C6? And what's C7 equal to? This is classic web work. Tell me C0. 0. What's C1? 1/8. What's C2? What's C2? 0. There's no x squared term. What's C3? Sign goes with it. Negative 1 over 64. What's C4? 0. What's C5? 1 over 512. What's C6? 0. There's no x to 6 term. What's C7? Negative 1 over 4,096. Does that make sense? Now, when you look at the next problems, I'm going to do these problems on a special video I'm going to create for you guys, because I'm doing web work problems on a video, and I'm going to post it on our Canvas page and stuff like that. But I especially want you to pay attention to this one, and especially this problem here, because power series are easy to manipulate. I'll talk about that in the video and in next class. So we'll start section 8.7 soon thereafter. So study hard, and I'll see you guys then.